To begin this topic of osmosis, we're going to look at this cartoon. And it says, do what he says, Walter. He's got a salt weapon. As you can see, there's 3 slugs, and he's got a salt shaker. And why would slugs be afraid of salt? We're going to talk about that. In our chapter 13, section 2, it talks about what a semi-permeable membrane is. It allows the passage of some particles while blocking the passage of others. So, your skin is a semi-permeable membrane. Your skin will let out water in the gas form, but not the liquid form. Otherwise, it would drain right out of your body. But you can sweat and so forth, and moisture will go through there. You've probably also got the other way where you were doing dishes or swimming or taking a shower, and you were in there too long and your fingers got all wrinkled up because the water went through the semi-permeable membrane and made it swell. What doesn't come out of your membrane is salt and sugar and all the things that are going through your blood vessels. So what is osmosis? It's the movement of a solvent through a semi-permeable membrane from a side of lower concentration to the side of higher concentration. That's osmosis, from lower to higher concentration. And we'll talk about osmotic pressure in just a moment. But first, let's take a look at this drawing similar to the one you have in your book. So let's say we have a glass tube, and it's full of pure water. And in this glass tube, we're going to put a semi-permeable membrane, kind of like your skin. And this membrane has little holes. Now, much smaller than what I'm drawing here, but we're just drawing to show that there are some holes. And the water is able to pass freely from one side to the other. But let's say we put some salt, some sodium here, some sodium atoms, some salt here, and some chlorine, sodium chloride. And now, which side is more concentrated? Pure water or the salt water? Well, this has got a higher concentration of what? Salt in the solute. Well, the sodium and the chlorine cannot go through that membrane. It's only permeable to water. That's what it means to be semi-permeable. So, the water is attracted to these ions. That's why it will dissolve in the first place. And so these water molecules also want to get in on the deal, and so they're going to pass through this membrane in order to join the other side and get towards these other ions. Well, as this process continues, that means that there's more liquid on this side than on this side, and that's going to raise this up on this side, so the water level will rise to that new level. Well, if that side goes up, this side will go down. Now, how far will it go up or down? Well, the attractive force is pulling the water across this way. But as this goes higher and this goes lower, there's going to be a difference in pressure because this water has weight and it pushes down, and it's going to want to push things back. Well, the salt can't go through, so only the water can go back. So the water, pure water, is going to go across this way until the weight from gravity is so great that the water molecules going across will be equaled by the water molecules going back across. And we will read a state of equilibrium here. And this difference is called osmotic pressure that keeps these two things separate. Well, what if we were to have water, salt water on this side and a semi-permeable membrane on this side and no water on this side? What would you predict happen? Well, just like the gravity over here is trying to make the water molecules get to a point where there's just as many going back over as we're coming across, so here the gravity is going to push water molecules across to the other side. But since there's no water molecules on this side, there's none to go back. and water molecules will continue to go across. Well, what's going to be on this side? Pure water. So we could do a situation where we get some salt water, a semi-permeable membrane, and push the water molecules across and leave the impurities, the salt or whatever's in the water, behind and getting purified water. And so you'll see on your water bottles and so forth, sometimes it'll say the water was purified by reverse osmosis. And that's this process right here. So let's come back to our snail friends and take another look at a joke. Here's a Far Side comic strip, and this is a car full of slugs, and it says, "Hey everyone, time for a swim." And it says here, the Great Salt Lake, slug vacation disasters. And one more Far Side to conclude our thoughts on osmosis. Here is Mama Slug and Young Slug, and it says, "Eddie, I've told you 100 times never to run with that through the house." And what's he carrying? A salt shaker. What would be the concern? Why, he could spill that, and if they were to go across it, it would kill him. It's the same reason why you shouldn't drink salt water. If you are lost at sea and you're super thirsty, should you drink the water of the ocean? No, because that salty water is going to pull the less concentrated water across the membrane in your body and actually dehydrate you and take water out. So too much salt is not only bad for slugs and snails, it's bad for you and everybody else. And it's also why freshwater fish will not survive in salt water, because they have not used to this, and fish that are in salt water have to have a pump to keep themselves from being dehydrated. So that's it.